Like that you can deal with the problems related to parabolas. It is not over. There are so many such things. As and when the situation demands, we shall go through those problems once again. Now let us have a look over an ellipse. We all know that the standard form of an ellipse is x square by a square plus y square by b square is equal to 1, and its area is pi AB, as we could already derive it. Answer is pi AB. Now the question before us is area of the ellipse x square by a square plus y square by b square is equal to 1, bounded between the two latus recta. Bounded between the two latus recta. What is the area? Let us have the figure. Observe the ellipse. This is the major axis. This is the point A0 and this is the point minus A0. These are the ends of major axis, and this is one end of minor axis 0B, another end of the minor axis 0 minus B, and somewhere else here it is the focus, and this is the latus rectum. Another latus rectum which exists by the symmetry of the figure is this, and we require the area between these two latus recta. These two latus recta. This is the point AE0 and this is the point minus AE0. My dear friend, by observing the symmetry of the figure, this area, this and this are absolutely same, isn't it? As the equation of an ellipse contains both the even parts of x and even parts of y also, it is symmetric about both x-axis and y-axis. By making use of that symmetry, you see that area, the required area, can be taken as 4 into this particular area or 4 into this particular area, like that, as you like it and as you can. Required area is equal to 4 into integral 0 to, come on, I like to find this area, 4 into 0 to AE, 0 to AE. This is the curve x square by a square plus y square by b square is equal to 1, and from that you must be able to have y. How? Look here, y square by b square is equal to 1 minus x square by a square, that is equal to a square minus x square by a square. Okay, therefore y square is equal to plus or minus b by a into root of a square minus x square. And we are moving under the curve in the first quadrant, therefore y is equal to b by a into root of a square minus x square dx. Isn't it? X square by a square plus y square by b square is equal to 1. So y square by b square is 1 minus x square by a square. It's nothing but a square minus x square by a square. So that y square is equal to b square by a square into that, or y is equal to plus or minus b by a into root of a square minus x square dx. Okay, so this is 4b by a into, come on friend, have the integral x by 2 into root of a square minus x square plus a square by 2 into a square by 2 into sine inverse x by a between the limit 0 to a. Good. This is equal to 4b by a into, put AE first, AE by 2 into root of a square minus a square e square. You can collect the formula. B square is equal to a square into 1 minus e square. In the case of an ellipse, you might have forgotten it. What is b square? Actually, a square into 1 minus e square. But a square into 1 minus e square is a square minus a square is e square b square. Root b square is b. Here, what happens? Plus a square by 2 into ae by a is e sine inverse e. Minus, you put 0. What happens? 0 into this is 0, 0 into this is 0. No problem at all. So, this is the answer. Hence, here you can cancel a and a. Here you can cancel a and a, or this is 4b by a into root of a square minus a square minus a square. E square is nothing but b. Therefore, ab into e by 2 plus a square by 2 into a square by 2 into sine inverse e. If you send a inside, it becomes 2b into be plus a sine inverse e. That gives you the answer. That is the answer between the lattice recta. Okay? Like that, you can find the answer. The next question is, find the area of the quadrilateral formed by the tangents at the ends of lattice recta of the ellipse x square by a square plus y square by b square is equal to 1. This is also a famous answer, famous question, of course. Let us first understand the question, what has been asked. We are supposed to find the area of a quadrilateral formed by, what are the 4 lines which form the quadrilateral? The tangents at the end of lattice recta, ends of lattice recta of the ellipse, x square by a square plus y square by b square is equal to 1. Okay, the tangents have been drawn to the ellipse at the ends of the lattice recta. Okay, let us first observe the diagram. This point is the focus, of course, AE, 0, and this point is the other focus which has existed according to the symmetry of the figure about both the axes. Okay, and these two are the ends of lattice recta. One tangent like this, another tangent like this, and ends of lattice recta. One tangent like this, another tangent like this, another tangent like this, and these tangents when extended back meet on y-axis. Well, by symmetry of the figure, we like to find this area first. 4 times of that area gives you the area of the entire quadrilateral. Okay, this point is, of course, AE comma b square by a. You please remember that the length of latus rectum of an ellipse x square by a square plus y square by b square is equal to 1 is 2b square by a, and hence this length is b square by a. This length is also b square by a, and hence the y coordinate of this end, this particular end of the latus rectum is b square by a. Well, let us find the tangent at AE comma b square by a. Tangent at AE comma B square by A is, come on, XX1 by A square plus YY1 by B square is equal to 1. You can cancel B square here, A here, so that it is X by A by E plus Y by A is equal to 1. Y by A is equal to 1. Therefore, x-intercept is A by E, that is this point is A by E comma 0. You can recollect, my dear friends, it is just nothing but the point on the directrix of the ellipse. Moreover, there has been a standard result in ellipse, that is the points drawn at the lengths of latus recta definitely pass through the directrix. The two tangents, directrix and axis are concurrent at AE comma 0. Well done. The x-intercept is A by E and y-intercept is A. Therefore, the area of triangle OAB. Let me call this O, this A, this B, is half into base into height, that is A square by 2E. A square by 2E. But total area is, required area is 4 into A square by 2E, that is 2A square by E, so many square units. 2A square by E. 2A square by E. Okay, friend. Let us think of the reusability of this result. Reusability of this result. So, the required answer is 2A square by E, so many square units. Okay, I am now giving you the ellipse x square by 9 plus y square by 5 is equal to 1. Here, A square is equal to 9, B square is equal to 5, E square is equal to 1 minus B square by A square, that is equal to 1 minus 5 by 9. 1 minus 5 by 9 is nothing but 4 by 9. Therefore, E is equal to 2 by 3. We could have got almost all the things here. What is the area? Such area of the quadrilateral formed by the four tangents to the ellipse drawn at the four ends of the two latus recta is, let us verify, is 2A square. A square is 9 by E is 2 by 3. This is 18 into 3 by 2. That is 54 by 2 is nothing but 27. Is nothing but 27 is the right option, right answer, isn't it? Okay, like this we can have the answer. Therefore, it is 2A square by E. Moreover, you can a beautiful reusability of the result is also there in this question. You, for the sake of practice, you please tell me the so-called area for the ellipse. X square by 16 plus y square by 9 is equal to 1. What is the area? What is A square? 16. What is B square? 9. What is E square? 1 minus 9 by 16. It is 7 by 16. What is E? Root 7 by 4. What is E? Root 7 by 4. So the answer is, the required area is 2 into A square, 16 by A. A is root 7 by 4. Hence the answer is altogether 2 16s are 32. 32 4s are 128 by root 7, so many square units. And you need not to draw all this figure, estimation, nothing, etc. No, not at all. Not necessary at all. You just have the answer as 2A square by E is the area bounded by the four tangents that have been drawn at the four ends of a latus recta. Let us now go through some general problems. Consider the problem. The area bounded by y is equal to mod x minus 2, x is equal to 1 and x is equal to 3 and x-axis. Of course, he has given certain options 1, 2, 3 like that. Let us verify by getting it solved. First of all, you see y is equal to mod x minus 2. It does mean y is always positive. That is, the graph lies above x-axis only. Okay, how to imagine it? There are two lines in it, y is equal to x minus 2 and y is equal to 2 minus x, isn't it? Okay. Where does this meet x-axis? At x is equal to 2, y is equal to 0. Therefore, from 2, this is y is equal to x minus 2. This is y is equal to 2 minus x. Y is equal to 2 minus x. This is 2, isn't it? X equal to 1, just 1 unit back. X is equal to 3, just 1 unit towards right. So this is the required area. This is the required area, isn't it? Equation of this line is y is equal to x minus 2 and equation of this line is y is equal to 2 minus x. This is 1, this is 3. Come on friend, if you take x equal to 1, y is also 1, hence the point is 1 comma 1. If you take x is equal to 3, y is 3 minus 2 is 1, hence this point is 3 comma 1. Well, my dear, you need not use integration at all. Justly by the geometrical appearance, you can have the area directly. Why? Because this distance is 1. This distance is 1. Here it is 1. Here it is, come on. Distance is 1, 1, 1, 1, 1. Required area is equal to half into base into height, half into 1 into 1. Again there also half into 1 into 1. Total half plus half is 1 square unit. And this is the way we interpret the nature of the equations given in the data. And between those boundaries, we can have the area directly even without using integration concept. We can have it, no doubt. Yes, let us observe one more such problem. Next question is ready on the board for us. You please follow that. The area bounded by y is equal to mod x minus 1 and y is equal to 3 minus mod x. Let us observe the graph. This meets x-axis at x is equal to 1, of course. This is y is equal to x minus 1. This is y is equal to 1 minus x. I would have taken in the first or second quadrants only because y is equal to mod x minus 1 is given. That is, y is always positive. You are not supposed to enter into either third quadrant or fourth quadrant. Well done. Y is equal to 3 minus mod x. What do you mean by that? If x is positive, mod x 3 minus, one line is 3 minus x, another line is 3 plus x. Isn't it? One line is y is equal to 3 minus x, another line is y is equal to 3 plus x. Where do they meet actually? How to write y is equal to 3 minus mod x? 3 minus mod x. It meets y-axis at x equal to 0, that is x is equal to 3. And meets x-axis at plus or minus 3, isn't it? Plus or minus 3. One line is this, another line is this. This is 1, this is 3, this is minus 3, and this is 0, 3. 0, 3. Good. Look here. The four lines surely form a rectangle. the 4 lines form a rectangle. Look here, this is 1. This point is 1, 0. This vertex is known. What is this line? Y is equal to 3 minus x. Y is equal to 3 minus x and y is equal to x minus 1. What is the point of intersection? Y is equal to 3 minus x and y is equal to x minus 1. If you can equate them, 3 minus x is equal to x minus 1. So 2x is equal to 2. So x is 1, isn't it? Let us find these points of intersection. Y is equal to 3 minus x and y is equal to x minus 1. Where do they meet? 3 minus x is equal to x minus 1, so that 3 plus 1, 4 is equal to 2x, or x is equal to 2. Hence, for this point, x coordinate is 2. If you put x equal to 2 here, y will be 1. This is the point 2, 1. This is the point 1, 0. And this is the point 0, 3. What is say about this? This is y is equal to 1 minus x and this is y is equal to 3 plus x, isn't it? So, here this line is y is equal to 1 minus x and this line is y is equal to 3 plus x. 3 plus x is equal to 1 minus x. 2 is equal to minus 2x. So, x is minus 1. Hence, this point is minus 1 comma 2. Well done. All the 4 points have been obtained. You find, you see, you can observe one thing. These two are perpendicular. These two are perpendicular. Hence, it is surely a rectangle. Oh, okay. How are they perpendicular? Slope is 1, slope is minus 1. Here also slope is 1, slope is minus 1. They are perpendicular. Hence, they form a rectangle. Well, what is the distance between these two? 2, 1, 1, 0. Square root of 1 plus 1, that is root 2, isn't it? What is the distance between them? Square root of, difference is 1, square is 1, square is 1. This is root 2. What is the distance between them? Difference is 2, square is 4, 4 plus 4. This is 2 root 2. Isn't it? So, length is 2 root 2, breadth is root 2. Therefore, area is equal to 2 root 2 into root 2. Hence, the answer is 4. Hence, the answer is 4. Like that, we have the area. Even in this problem also, we did not use the concept of integration. You could have just noted or traced the nature of the diagram. As it is a rectangle, we have used the formula length into breadth to have the area directly, and the answer is 4 square units. The next problem. The area between y is equal to mod of mod x minus 1 and x-axis is, that is the beautiful question before us. Mod of mod x minus 1. Again, 4 lines are there. Let us first imagine the graph. Where does it cut x-axis? At 2 points. If y is 0, mod x minus 1 is 0, mod x is equal to 1, hence x is plus or minus 1. Look here. What are the 4 lines here? Y is equal to mod x minus 1 and y is equal to 1 minus mod x. If y is equal to mod x minus 1, the 2 lines are y is equal to x minus 1 and y is equal to minus x minus 1. Here, y is equal to 1 minus x, y is equal to 1 plus x are the 4 lines. Okay, as y is mod of that, we have given the graph like this. We did not enter into the 3rd quadrant or 4th quadrant. Well, note down the points. This is minus 1, 0. This is 1, 0. Where does it meet the y-axis? It is 1. It is 1, 0, 1. So, this area and this area we want. This is the midpoint, of course, 0, 0. This is 1, this is 1, this is 1. What is the area? First part, half into base into height. The second part, half into base into height. So, the answer is 1 square unit. The answer is 1 square unit. everything lies in tracing the graph. In tracing the graph. You follow the question? The next question is before us. Y is equal to 1 minus of mod x minus 1 on x-axis. Here also, the role of the graph is very important. First of all, let us observe where does this cut or meet x-axis. Y is equal to 0. Mod x minus 1 is equal to 1. Mod x minus 1 is equal to 1. Mod of mod x minus 1 is equal to 1. So mod x minus 1 is equal to plus or minus 1. So mod x is equal to 1 plus or minus 1. So mod x is equal to 2 or 0. So x is 0 or plus or minus 2. Altogether, how many points? 3 points will you have. You please follow that. 1 minus mod of mod x minus 1 is equal to 0. Mod of mod x minus 1 is equal to 1. So mod x minus 1 is equal to plus or minus 1. Mod x is equal to plus or minus 2. Mod x is equal to plus or minus 2. Mod x minus 1 is equal to 1. Mod of mod x minus 1 is 1. Therefore, mod x minus 1 is equal to plus or minus 1. Hence, mod x is equal to 1 plus or minus 1, 2 or 0. So, x is equal to 0 or x is equal to plus or minus 2. So, at how many points this curve meets x-axis? At 3 different points. How many different points? 3 different points. What are the 3 different points? Minus 2, 0 and 2. Well and good. Where does this meet y-axis? Where does this meet y-axis? X is equal to 0. This is what happens? 1 minus. Where does this meet y-axis? Can it meet y-axis? Of course, at origin. At origin. Therefore, the line will be, yes, by expanding this, removing this modulus, and all the 4 lines can be seen like this. And this is of course the required area. Okay, what are these vertices? What are these vertices? What is this line? You find all these lines. You can have 4 lines from this by expanding modular symbol, and you can easily see that the vertices are minus 1 and minus 1 1 and 1 1. Now you can easily have the answer. Look here, minus 2 0. This point is minus 1 0. This point is 1 0. Come on friend, area of this triangle, required area is equal to area of the first triangle. What is that? Half into base. What is the base? 2 into, isn't it? The length of the base is 2 units and the height is 1 plus again half into 2 into 1. So it is 1 plus 1 is equal to 2 square units. So everything lies in tracing the graph. In tracing the graph. You follow carefully about the nature of the graph. What is the area bounded by mod x plus y plus mod x minus y is equal to 1? Again here also 4 straight lines will be will be obtained. What are they? Assume that both are positive. X plus y plus x minus y is 1. 2x is 1. So x is equal to half is one line. Suppose both are negative. This is minus x minus y. Minus x plus y is equal to 1. Y will be cancelled. Minus 2x is equal to 1. So x is equal to minus half. Another line. Suppose this is positive and that is negative. X plus y minus x plus y is equal to 1. So 2y is equal to 1. So y is equal to half is another line. Suppose this is negative, that is what I mean to say is x plus y is negative and x minus y is positive. What happens then? Minus x minus y plus x minus y is equal to 1. X will be cancelled, minus 2y is equal to 1, hence the answer is y is equal to minus half. You plot all these graphs, all these straight lines on a graph paper. What can you have? This is y is equal to half, this is y is equal to minus half, this is x is equal to half, this is x is equal to minus half. All together this point is half comma half, this point is minus half comma half, this point is minus half, and this point is half comma minus half. You can easily understand, you can easily believe that the diagram that is formed by all these straight lines is absolutely a square, isn't it? Is a square. What is the length of each side of the square? Come on, find it. This is half, so total it is 1. Isn't it? So 1, 1, 1, 1. Area is 1 square unit. Isn't it? What is the distance between these? Half, half, so 1. Or else you just find the distance. Half 1 minus of it is 1. So it is the diagram which is going to be obtained by plotting all the graph, all the straight lines given in the data is surely a square in which each side is of length 1 unit. Hence the area is 1 square unit. So answer is 1 square unit. 1 square unit. Yes. So the area, required area is 1. Here also we couldn't use any integral concept here. You see? So the main thing that you must have in your mind is you must be able to trace the graph of the functions given in the problem. Yes. So the answer is 1 square unit. Let us look at another question. Another beautiful question is before us. Let us look at that. 3 circles, rather 3 coins have been placed, touching each other, and by common tangents form an equilateral triangle. What is the area of that equilateral triangle? How many coins are there? You please observe the question once again. 3 coins, of course, which are circular, placed side by side, touching each other. You need 2 of them touch. Then the common tangents to any 2 of them form a triangle, an equilateral triangle. He says, what is the area of that equilateral triangle? Okay, let us try to draw. This is 1 coin. This is another coin. This is the 3rd coin. This is a common tangent. Another common tangent. And the 3rd common tangent. And from data he says that it is an equilateral triangle. It is an equilateral triangle. The radius is 1 unit. The radius is 1 unit. The radius is 1 unit. He has said it. The radius is 1 unit. This length is 1, 1. Moreover, as we are supposed to have the area of this equilateral triangle, formed by the common tangents to any two of the circles. How many such common tangents are observed in the figure? 3 common tangents, and these 3 common tangents of course form a triangle, and from data it is noted that it is an equilateral triangle, and we want to calculate the area of that equilateral triangle. That is the present question. Look here, this is also radius, this is also radius, this distance is 1 plus 1 is 2. This is 2 means this is also 2. One more thing. Can you tell me the angle here? The total angle is 60 degrees. Why is it 60 degrees? Because it is an equilateral triangle. And this is a bisector, isn't it? So therefore, what is this angle? 30 degrees. 30 degrees. Let me name the triangle ABC. Let this be the point D, let this be the point E, and let this be the center of this circle O. From triangle OBD, what is cot 30? What is cot 30? Adjacent side by opposite side. What is the adjacent side? BD. What is the opposite side? OD. It's equal to BD by OD. What is OD? 1. Hence from this, what can you say? BD is equal to cot 30. Similarly, absolutely in the similar fashion, you can have CE is also cot 30. Why? Because as this is 60 degrees, this is also 60 degrees, and if you can draw another line like this, this is also 30 degrees. Okay, therefore this is cot 30, this is cot 30. What is cot 30 actually? What is cot 30 actually? Tan 30 is 1 by root 3, whereas cot 30 is root 3, isn't it? So this is root 3, this is root 3. Oh, successful. We are able to have the length of each side of this equilateral triangle. What is BC? Root 3 plus 2 plus root 3, and what does it does mean? 2 plus 2 root 3. Let me call this A. Let me call this A. We have had the length of each side of the equilateral triangle in the present figure, and as you know the length of each side of the equilateral triangle, you can trace the area directly. What is the area? Root 3 by 4 a square. Therefore, required area of triangle ABC is equal to root 3 by 4 into a square. Root 3 by 4 into a square. That is root 3 by 4 into 1 plus root 3 whole square. Therefore, the answer is root 3 into 1 plus root 3 whole square. If you want, you can expand it, or otherwise you keep it like that. So that is the area. Beautiful problem. The figure you may have to trace, of course, and you have to understand the sentence given in the problem. The 3 coins are placed adjacent to each other in such a way that any 2 of them touch each other externally. Any 2 of them touch each other externally. Like this, they are placed. And for any 2 tangents, for any 2 circles, you can draw a common tangent. This is a common tangent, this is a common tangent, and this is a common tangent. All those common tangents form a triangle, and from data it is given that it is an equilateral triangle. It is equilateral triangle, we believe it. Even though if he doesn't give it, we can understand that it is an equilateral triangle. Okay, and its area is root 3 into 1 plus root 3 whole square. That's all. Nice of it. The only thing required here is you have to find the length of each side of the triangle. For that, so far it is 2, it is understood. It needs us to know this distance and this distance, and by symmetry, as it is an equilateral triangle, it is just enough if you can know this bearing. And we could have made use of trigonometry by using card 30. We could have had bearing. Similarly, absolutely in the similar fashion, you can have C also. So this is root 3, that is root 3, altogether it is 2 plus 2 root 3, or 2 into 1 plus root 3. If you square it, 4 into 1 plus root 3 whole square. Do you want to simplify? You can. This is root 3 into 1 plus 3 plus 2 root 3, 4 plus 2 root 3. Root 3 into root 3, 3. 3 2s are 6. 6 plus 4 root 3. So many square units is the right answer.